Please welcome science journalist and STEM lead of the Lightyear Foundation, Claire Malone.
Have you ever taken your 3D glasses off at the cinema? The picture looks blurry and it can be difficult to see exactly what is happening. This is because 3D glasses trick our brain into forming a 3D image by controlling the color of the light that each eye sees, using a different filter in each lens. You could say, sometimes seeing things from a different perspective can make them look clearer and easier to understand. This is exactly the approach that has helped me with my research, looking to answer some of the most fundamental questions we have about our universe. To put this in a different context, I could see some people finding my voice difficult to understand due to my cerebral palsy, as an insurmountable barrier to giving this talk. Even if I saw that there are alternative ways for people who have difficulties with communication to speak to an audience, I could be put off from using them, thinking that this dry computerized voice has no life in it, and would put you all to sleep within 5 minutes. Alternatively, I could see the dodgy, female, British synthesized voice as something to be embraced, pepper this talk with jokes and gags, sometimes at the poor iPad's expense, and, hopefully, make you laugh and keep you engaged with what I want to tell you about. Luckily for you, I have chosen the second option. And what do I want to tell you about? I'm here to tell you that we have completely misplaced 96% of the entire universe, everything in existence. That's an awful lot of missing socks. I'm a particle physicist, and during my PhD, I analyzed data from the Large Hadron Collider at CERN in Switzerland to answer the most fundamental questions about our universe. My research examined what I truly believe is one of the greatest achievements of scientific research in the last century. A model that describes the properties and behavior of all the known particles in the universe, and as physicists have no imagination, we call it the Standard Model. For me, having one model with so much power is as close as science gets to describing nature at its most basic level. Thinking about this gave me the passion to focus on my studies in physics. I also knew that I would have to think about them a little differently to my fellow students. For example, I had to demonstrate in examinations that I had understood the practical techniques that I had been taught. Due to my disability, I don't have enough control of my hands to be able to use laboratory equipment. So I had to borrow someone else's hands. I practiced giving extremely detailed instructions to my assistant about how to use the equipment in order to perform the experiment. Seeing experiments from the perspective of a series of instructions that I had to give as clearly as possible really helped me get into the mindset I needed to understand how I could perform well in my practicals, which I did. Recognizing that I was able to look at such issues in a different way gave me the tenacity to persevere with mastering the practical side of my scientific studies, rather than letting my physical limitations stop me. It does take a slightly different mindset to speak your work. However, I have found that thinking that I am doing basically the same actions as everyone else has helped me to understand how to proceed in pursuing my passion for physics. Now, let's get back to my favorite model, and hopefully yours, after this talk. Because unfortunately we have a major snag. The Standard Model only describes 4% of the universe. To understand why, you have to look at how fast galaxies are spinning. Newton's laws tell us that they would simply fly apart if there wasn't some kind of massive substance within them to bring them together. This missing mass, called dark matter, is observed to account for 23% of the universe. So what about the rest? Well, the discovery that the expansion of the universe is accelerating, rather than decelerating due to gravitational attraction, points to the existence of a force acting against gravity. We call this force dark energy, and it accounts for the remaining 73% of the universe. Neither dark matter nor dark energy are included in the Standard Model. So there is a staggering 96% of the universe that we know absolutely nothing about. It turns out that my favorite model, that I thought could describe every particle in the universe, isn't as all-encompassing as I initially thought. So, is there a way to look at our experiments differently, in order to discover these absent particles? We have had to accept the fact that the missing particles are not going to interact with our detectors, whatever we do. But that's not game over. In the same way that I didn't give up on being able to do lab experiments myself, but instead used someone else's hands, we use the particles that we can detect to spy on the particles that we think are there, but hiding. Enter CERN. CERN collides particles together at close to the speed of light, releasing enormous amounts of energy. When these particles collide, head-on, the really interesting physics happens. With such colossal amounts of energy released, particles fundamentally different from the ones that we began with are created. It's like if you smash two apples together expecting them to turn into a pile of cherries. Using sophisticated detectors, we can tell what kinds of particles have been made, but only the types we already know about. So how are we going to find these other mysterious particles? Fortunately, a fundamental law of nature comes to our rescue and allows us to study these particle collisions from a different perspective. Energy can neither be created nor destroyed, only transferred. When you add up the energy of the particles before and after the collision, you find that they are equal. We know the energy of the particles entering the collision, and we make very sensitive measurements of the energy of the particles leaving. If those two energies are not identical, alarm bells start to ring. Perhaps, one of the principles that underpin our understanding of nature, conservation of energy, is incorrect. Or, as everyone is hoping, the missing energy could have been stolen by particles that elude our detectors. I know what you are going to ask me. Have you found the missing particles yet? Sadly, no. Some people might lose hope that we are never going to fully understand the basic building blocks of the cosmos. However, I think that this is perhaps the most exciting time to be conducting fundamental physics, as we have so much left to discover. In addition, I find that being open to seeing a situation from a different perspective is more meaningful when applied on a personal scale. It encourages you to seek out the positive in each person and situation, no matter how difficult, and use it to bring out not only our own potential, but that of those around us. I feel this is something we could all benefit from at the moment. It doesn't always mean that you'll find what you're looking for right away, or that it will be easy. But for me, this mindset helped me get where I am now. Today, we are surrounded by big questions, without obvious answers. Perhaps by embracing a new way of thinking, by being truly open to other people who don't share our perspective, we might just be able to discover new solutions to the problems we are all facing. Thank you.